Okay, so next problem. I think we have to try this one for me to learn. Maybe also, I don't know with you, but it's part of learning course. I think I should try 13.10 because this is exactly the opposite of this 13.9. Uh, I'm telling you that there are problems like this. You have to write a balanced chemical equation from the galvanic shell. So I think I do have to do this so that I learn and so that I could also somehow share if ever. So you have your silver and platinum as an anode. Your silver is on the anode, I mean electrode. Talking about electrode, anode, and a cathode. So starting from the left, that should be an anode. The negative side or the oxidation happens. That is the loss of electron happens, wherein that is a site where electrons are being generated. As you can see from Leora or loss of electron, your electron is on the right side, meaning it's a product. So we can represent that one in terms of silver to silver ions. So the half reaction, of course, you can always start here with oxidation because your oxidation, that should be from the left, of course, meaning that should be the Ag going to your Ag plus. As you can see, you have to have one electron here for that half reaction to be balanced. Okay? So no other information is given. So we can see that's already okay. And then next one, you have your Sn4 and Sn2. So therefore, that should be acquisition of electrons. That is Sn4 to Sn2 plus. Okay, and then platinum is just an electrode, meaning it doesn't participate in the reaction. It will just be a metal wherein your electrons will flow through. Okay, but it is not part of the oxidation reduction reaction. So what takes part is the Sn4 plus going to Sn2 plus. So the reduction would be reduction. So the reduction would be as an Sn4 plus going to Sn2 plus. And basically, you have to gain 2 electrons for this. So that positive 2 should be balanced. So balancing this one, should multiply this by 2. You have Ag, 2Ag, and then you have your 2Ag plus, then you have 2 electrons. So basically, you can cancel those 2 electrons and you can write from oxidation to reduction. Since there's no given, so here the default would be from oxidation to reduction. So we would start with Ag always. So Ag, 2Ag, and then that is solid. You can actually put now the notation silver solid, and then you have your Sn4 plus, Sn4 plus, and then it will have a product of 2Ag plus, 2Ag plus, and then of course your Sn2 plus. So you can see that it's balanced. You have two silver. You have one Sn, one Sn. How about charge? Zero charge here. You have four positive. You have 2 times 1. You have 2 positive and 2 positive. So that would be equal to 4. This is now a balanced chemical reaction from both half reactions. So that's how you should answer this type of problem for A. How about for B? You have, this is also simple. As you can see, there is no other thing, but meaning the electrons are also involved with the reaction. So there is an aluminum to Al3 plus. That should be oxidation. Al to Al3 plus. So letter B. So letter B, that should be oxidation. Ox na lang. Al2 Al3 Al3 plus. So that is oxidation. That is loss of electron. That is oxidation. So you have to put 3 electrons here. Okay, how about the reductions? Red, reduction. So I think this one is simple. You you have copper 2 plus going to copper. So copper 2 plus going to copper. So that would be copper 2 plus, and then it makes copper. So you can actually you can see that you need two electrons for this one. Um, two electrons for that one, and that should be balanced already. So you multiply this by 3 and you multiply this by 2. So you have, we start with aluminum, 2 aluminum, then it proceeds to uh, 2 Al3 plus, then you have 6 electrons. Then next you have 3 copper 2 plus and then plus 6 electrons. Then it goes to 3 solid copper. So you can sum it up. You can cancel the 6 electrons. Then you can bring down from oxidation to reduction. So that would be a 2 Al. And then plus, of course, your 3 Cu2 plus. Then goes to 2 aluminum. 2 aluminum 3 plus. And then it will, next is 3 copper. So that's very simple. So aluminum balance, 3 copper, 3 copper. How about the charge? You have 6 here and you have 6 here. So that's kind of balance for letter B. How about for letter C? You have platinum. At both of the electrodes are platinum. But as you can see, your platinum doesn't take part of the oxidation reduction reaction. So meaning we only have to write iron. Iron, Fe2 plus and Fe3 plus for the oxidation. So can disregard the platinum. So you have the Fe3, Fe2 plus, oxidation, Fe2 plus going to Fe3 plus, and then you'll write, of course, you need one electron for this one to be balanced, and then we go to the reduction. To the reduction side, so for the reduction side, here's my MnO4 to Mn2 plus. So you have your MnO4, MnO4 to Mn2 plus. So that should be balanced with, of course, H2O. Should write H2O here for 4. So this should be 4, 4 oxygen. And then you should write how much? You should write 4 hydroxide ion. Now the problem is, what is this? Is this an acid or a base? That seems to be a problem. Actually, you can look for it at the table of ions. I think that, anyway, let's just continue first. Because these substances are listed in the table of ions, MnO4, Mn2 plus. So there are two tables for that. That is acidic and basic. So you just have to look it up. Anyway, you can, at least you can just do this. So in terms of charge, this is negative 1. Again, that 1, negative 1, and then 4, you have a positive 5 here. How about this side? This side, you have a positive 2, a positive 2. So basically, you should put a positive 3 here. A plus 3 electron, I mean, negative 3. Okay? So that it would be balanced. So you have 1 here, you have to multiply this by 3. So basically, that would be a 3 Fe2 plus, and then it would be a 3 Fe3 plus. Then you would have 3 electrons. Then on the other side, you would just copy it because you've already managed to balance it. Then you have your 4H plus, and then plus 3 electrons. Then it produces Mn2 plus, and then your 4H2O. So the 3 electrons is cancelled. So basically you have a 3Fe2 plus. Then next would be an MnO4 negative. Then next is 4H plus. Then next would be a 3Fe3 positive. Then your Mn2 plus. And then lastly, finally your water. So let's see if it's balanced. 3 Fe, yes, Mn1. O 4 is 4, yes, 4 hydrogen. 8, you have 8 hydrogen. Oh my, this is somewhat wrong. Sorry, because I've made it wrong here. See? So this should be 8. Actually, this should be 8 because you need 8 hydrogen for this. So meaning, anyway, this is multiplied, so this must be an 8 hydrogen. That's my fault. So you have 8 hydrogen, you have 8 hydrogen, you have 4 oxygen, you have oxygen. So basically, it's balanced atomically. So we will see the charges. 3 times 2, that's a positive 6. This one is a negative 1. This one is a positive 8. So that is 8, 16, 8, 6, 8, 6, that is 14, minus 1, that is a positive 13. How about this side? 3 plus 3 times 3 is a positive 3. And then you have a positive, oh my, 3 times 3, positive 9, I think. And then positive 2. So that must be a positive 11. Is this wrong? 8, 16, 14 minus 13. Oh my. So this is wrong. Where is my mystic? Mn0404 negative. So maybe I am just wrong. How about O4? O4, that is, sorry, because this is 8 8 positive and 3 negative 4. So 8 minus 4, that should be a positive 6. So if that's a positive 6, you need, no, positive 2, positive 8. So this is not 3. So that's my bad. So negative plus negative is 7. 7, you need a 5 for this one. 5 electrons for it to be a 2 positive. So this should be multiplied by 5. Let's see if I can already get this correct. So multiplying this by 5. So this should be 5. This should be 5. This should be 5. This is already 5. Okay. So what remains is this should be 5. Still the same, still the same. This is 5. Then still the same, still the same. Okay, let's see. So that could be a positive 10. This is a negative 1. This is a positive 8. So total is 18 minus 1. That is a positive 17. How about here? You have a positive 15. Then you have a positive 2. That is a positive 17. So this is now a balanced equation with 5. Okay. So that's the balance equation, 5Fe2 plus, and then you have MnO4, 8H plus in acid. If that is in base, though, that's a problem. I think we have to look at your um, Mn and MnO4. If it occurs in base or in acid, we can look. I think this acid. Anyway, let's see if we can get something out of this. Your Fe and Fe2 plus. Where is your ion listed? Fe3 plus Fe2 plus. Fe2 plus to Fe3 plus. So it's kind of reversed. Because we have an oxidation. Because we have an oxidation, so this should be reversed. Because this is a reduction potential. So this is listed in terms of reduction. So that should be reversed. Yes, that's okay. I think that is. Okay, but that is listed again in the acid. This is acid, half reaction of acidic solution. So your Fe is listed in the acidic solution. How about your MnO4 and MnO2? Here it is, Mn2 plus. So there it goes. MnO4 and your Mn2 plus is listed also in the acid. So meaning that is really an acid. So we don't need to put an H plus on this. Okay, that's how far as I understood this problem, how it should be written with a balanced. Take note, I might ask for again the thing that we're doing in balancing half reactions. I might do it and then I'll ask for the letters. That should be a 5 1 8 and then a 5 1 4. So there are 6 answers for this. So I might so just be ready. I think you can find problems like this in the book, or if ever you can see a half reaction of a galvanic cell, you can just figure out what is the balance uh, overall reaction with that, just like this problem. So just take note that I might give you problems like this, meaning what is A, B, C, D, E, and writing balanced chemical equations for the overall reaction of this galvanic cell. So just refer to this, that it could be done. Of course, this will test us how good are we really in making that half reaction. Then we come to, okay, I cut this video.